In this video, we are going to discuss the distributive property. Now, this property is an incredibly important concept to understand when you are preparing for Algebra 1. Now, fun part here is somewhere in this video, there may be a special little piece of information that you're going to want to be looking out for. Now, you'll know when it happens, so make sure you have your eyes and ears ready. When discussing the distributive property, let's consider playing Uno. I know you guys are passionate about Uno because I've heard you yell a lot during indoor recess about Uno. I also have heard the crazy rules you guys play by, but we're going to ignore all that for this video. For example, we're not talking about pluck and play. None of that will be discussed during this video. So, say in this game there are 3 different people. They are all going to go by mathematical nicknames because math is the best, obviously. So in this case we have x squared as a player, negative 4x is another player, and someone got a little bored and just called themselves 5. Now, each of these terms represent players in the game. Each player ends up getting 7 cards in a traditional game of Uno. Once again, I don't know how many cards you guys be dealing out during recess, but it's 7. No crazy rules are going to exist in this video. Now, what is important when starting a game of Uno is that you distribute the same amount of cards to every player, right? It wouldn't be fair if one person got 12, another got 5, another got 6. That wouldn't be a fair starting point. So, we can look at this one of 2 ways here. You can look at this as having 7 copies of x squared, a negative 4x, and 5 all needing to be added together. Or you can simply apply the distributive property of multiplication, since we know adding the same value over and over again is the exact same thing as multiplication. So let's distribute using multiplication. Notice the 7 must go to every term inside the parentheses. We want the game to be fair, so we cannot leave anyone out. So in this situation, we cannot simplify by combining like terms, because there is no like term after we did the distribution. In this example, we have a variable factor outside of the parentheses. This doesn't change the fact that it still needs to be distributed to every term inside the parentheses. Okay? When doing this, we need to be careful with what happens to our exponents. For instance, 3y times 1 squared ends up with a product of 3y cubed, which is the same as 3 to the 3rd power. Now, the reason that is you are basically multiplying 3 times y times y times y. That makes 3y cubed. Notice that y being multiplied 3 times. A similar thing is going to happen when we distribute the 3y to 2y. 3y times 2y results in 6y squared. Remember, this basically means 3 times y times 2 times y, and you can multiply in any order. So that's what gets the 6y squared. 3y times y to the 5th power results in 3y to the 6th power. And 3y times negative 9 results in negative 27y. So we end up here with our expression following using the distributive property. Now, once again, we cannot combine any terms here, or all of them, any of them at all. Although we have the same variable, right? To combine, in order for them to be like terms, they need the same variable and the same power, meaning the same exponent. In this case, that does not exist. If you need a review of combining like terms, make sure you look back at video 3. We're going to look at one more example, and I want you to make sure you are really thinking through and trying to work your way through this example. I might suggest actually even pausing the video and working your way through this problem. Now, here's where some fun is going to happen that I mentioned at the beginning. The first person to correctly reach out to me, you have to reach out to me directly through phone and email are fun, and give me the correct answer to this question, will get a small reward in the form of a gift card. If you already have the answer, that is great. If you already did it independently and have the answer and you paused the video and actually did what I asked, that's great. But I'm going to go over this to make sure you got it 100% correct. When distributing the 2z squared, I make sure I was distributing to every term in the parentheses. All right, hopefully at this point you have that understanding down pretty well. 2z squared times 5 results in 10z squared. 2z squared times z squared results in 2z to the 4th power. And when we distribute to the final term, negative 10z, we get a product of negative 20z cubed. This makes our final expression here 10z squared plus 2z to the 4th power, and then a negative or minus 20z cubed, which is our new equivalent expression. I just want to keep that in mind. When you distribute, you're making an equal or equivalent expression. Now, that's the answer. I only have one gift card, so the first person to send me that answer through text or email is going to get the gift card. So make sure you are first. Take out your phone now and get that done. Now, with video 3 and 4, we know how to combine terms now and use the distributive property. Make sure you get up there and practice, practice, practice. Video 5 is going to be a combination of distribution and combining like terms. So make sure you check back for that video and continue to practice, because who knows when I'll be offering up an additional reward for your guys' hard work.